Hello, welcome everyone. We're going to go through 3.4's guided notes. You can see I've got the answers for you right here. I'm going to go over the basics of what's on here, why the answers are what they are, and some intuition behind it. So the first part is some basic vocabulary. The first page is vocab. It says a transversal is a line that cuts two different parallel lines. So here's an example of such a thing. You've got two parallel lines and you cut them with a transversal. You should be drawing that in your guided notes. You should be drawing your transversal and labeling it as such. Why is it called a transversal? Well, it goes through, it transverses or traverses two different parallel lines. It just goes through them. You got this line that goes through two other parallel lines. Not necessarily always parallel, but we're always going to be working with cases in which they're parallel. Okay, well, let's see. If we have some examples of this in the real world, I was finding some, for example, here. In yellow, we've got our transversal, which is the road that is going across these railroad tracks, two different parallel lines. I just want to show you that you actually see these all the time in your daily life. Parallel lines are very, very common, just any two lines that are going a consistent width apart from each other. So the two parallel lines are shown in blue, and in yellow, you've got the transversal. I also found a pair of parallel lines in my apartment. I was just going by and when I was recording this, I was like, oh, there's an example of two parallel lines and a transversal. And you can see them right there. I literally didn't even have to get up, just there they were. We've got two parallel lines, in this case going up and down, and a transversal going side to side. Now the transversal doesn't always go side to side. It can go in any type of different direction. The transversal can go up and down. The transversal can go any direction, as long as you got two lines that are parallel to each other that cut two parallel lines. And this is not strictly always necessary. I would put a little asterisk next to this. Usually. They're usually parallel, though not always. Okay, we have some other key terms. These may or may not be things you've already learned. Supplementary means to add up to 180 degrees. Why would I be talking about 180 degrees? Well, in particular, you're always going to have, when two lines cross, you're going to end up creating what's called a linear pair. This is an example of that. So see, we've got a straight line and another piece, another ray coming out of it, making an angle. And those two create two angles, one on the left side and one on the right side, one on the right, one on the left. And those two angles together form a half of a circle. Not even like just part of a circle, but exactly half of a circle, because this line at the base is straight. Therefore, whatever this is plus whatever this is have to add up to 180 degrees, because that is a half circle. So, for example, let's say this is 130. Then this is how much? Well, 130 plus what is equal to 180, so that's got to be 50. Or if you have another one that is 100 degrees, what would be supplementary to 100 degrees? If you said 80, you're right, because it's got to add up to 180 degrees. 100 plus 80. Basically, I'm just doing 180 minus that other number. That's an example of a linear pair. It's called a linear pair because it forms a straight line together, adding up to 180 degrees. So linear pairs, in other words, you draw a linear pair like this, or like this, or whatever. The two angles it creates are always going to add up to 180. So if this one is 40 degrees, then this one has to be 140 degrees. They always have to add up to 180 because, that's the answer to our question, they form a straight line, 180 degrees. So linear pairs, which are these connected pieces formed by a straight line, these two angles next to each other are a linear pair. Why are they always supplementary? Well, they add up to 180 degrees. Last but not least in our vocab, we're talking about the interior and the exterior of an angle. or of two parallel lines. You've got two lines that are parallel, like here. So you got this line parallel to this line. The inside of those two lines is filled in. That is called the interior of the angle. And outside of those two lines, when you go everything except for the inside is highlighted in green over on the right-hand side. That is the exterior. This is the interior. This is the exterior. So shade that in, and you can see the angles that are formed by that, which over on this side I put in blue, and over on this side I put in yellow. Those are the angles that are created that are interior angles and exterior angles, inside and outside. Down here, I'm filling in each angle relationship with its name. One of them doesn't have a name. It's the very last one. The always congruent versus always supplementary. So remember, congruent means to be the same. Means if I can rigid motion one onto the other. These ones on the left here are always congruent, and these ones on the right are always supplementary, meaning they add up to 180 degrees. So when I add them up, I'll get 180 degrees. Here are the answers. This angle relationship is called vertical. Vertical has nothing to do with whether things are up and down, side to side, whatever. It has nothing at all to do with that. All it is the same word being reused in a different place. Vertical angles are basically opposite from each other. So you've got these two angles making this sort of bow tie shape are called vertical to each other. When you have two lines cross them over, that we make vertical angles. There's another pair right here. Those two are also, this and this, are also vertical angles. When you have a linear pair, on the right-hand side here, we have a linear pair, which we just went over. Remember, it's basically just a straight line with a ray coming out of it, makes a linear pair. And they're always supplementary to each other. Why? Because, well, they make a half circle. They make a straight line, which cuts a circle in half, so they're going to add up to exactly 180 degrees. So if this one is 30 degrees, then what does the other one have to be? That's right, 150 degrees. That's just an example. It doesn't always have to be that, but they just have to add up to 180 degrees. These ones on the top left here are called alternate interior angles. They're alternate because they're on opposite sides of this straight transversal. One is on the left, one is on the right of the transversal. And they're alternate because they're on opposite sides of it. They're interior because they're inside of the two parallel lines. We just did that up here. We highlighted the interior. This is the interior of those two lines. We've got same side interior, which is the same thing, except for instead of being on the opposite sides of the transversal, they are on the same side of the transversal. So they're inside, they're sandwiched in between the two parallel lines, and they're on the same side, either both on the left, both on the right, or if you turned it sideways, both on the top, both on the bottom of that transversal. They're same side, interior. You've got alternate exterior angles, which are on the opposite side of the transversal and are exactly opposite to each other, but on the outside. Here's the exterior that I'm highlighting. See how both angles fall on the exterior, and therefore they are alternate exterior angles. And on the other end, you've got your same side exterior angles. Same side exterior are exterior, but either both on the left, both on the right, whatever, they are on the same side and they're exterior. Key thing though is they can't be right next to each other. So all of these it can't just be this and this, because that would just be a linear pair. Can't just be those two. Those would form a linear pair. We also got corresponding angles here. We're going to go into depth on those. Corresponding angles are basically all in the same side relative to each other. You've got one interior, one exterior, always one in, one out. And they are in the same relative position. So you've got one in the top right and the other one also in the top right. These two are also corresponding angles, those two red ones. These two are also corresponding angles. This angle and this angle are corresponding, as well as finally, can you see the last pair? What does this angle correspond with? This angle. They're called corresponding because I can just translate them up and down to move one into the other. And the last one that has no name is also sometimes called baddie angles, and that was made up by my class last year. I just loved that. Tell me what you want to come up with, make up your own name. Or anti-corresponding angles, anti-corresponding. These are always supplementary, and what happens is you have one interior, one exterior, and they're on opposite sides of the transversal. So with corresponding, you've got one in, one out, and they're on opposite sides of the transversal. One down here, one up here. Not on opposite sides of the transversal, they're on the same side of the transversal. These are on the same side of the transversal. Same side, both on the right-hand side, but different vertices, one at the top, one at the bottom. And so they're corresponding. But if you have them being on opposite sides of the transversal instead, then they are this no-name thing, but they are supplementary, meaning they have to add up to what? Supplementary adds up to 180 degrees. All right, and that's it for this video.